This is the first video for Math 13.25 chapter 13.5. The handout was not very clear, so I decided to write this out. So remember last time we looked at some of this property, and we are taking integral of this to find the area under the curve, right? So if it's between A and A, there's no area at all, so this is going to be 0. But if we go from A to B, for the integral of f of x dx, it will be the same as from B to A, but you need to multiply a negative. The next one is if you're taking an integral and you have a constant here, so you basically pull out a constant. And the next one, if you are taking integral and there are two terms adding and subtracting together, you basically can take them individually as each term. The next one, I know this is kind of looking weird, but the graph say A, C, and B, right? So if you're taking integral, finding the area from A to B, that would equal to, you're taking the integral, so finding the area between A to C, and then adding the area from C to B. So these are some of the property we kind of have looked at before. If you need to pause the video and write it down, please feel free to do so. And see, I told you it's not very clear. So the method of substitution for definite integral. So we did some of the substitution, but it's for indefinite integral with the C, right? So this time we are using the substitution method for definite integral. So this is a little bit more complex. So we can use substitution to undo taking integration of a chain rule. So be very careful, make sure you adjust the upper and lower limits when you do substitution, okay? So let's try an example together. The first one, I know this is chain rule because I have a function here, raised to a power, right? So immediately, hopefully, you now know you should let whatever inside here equal to u, x squared minus 1. And then we will take du, right? Du would be 2x dx. So I only have an x here, so I don't have 2x, so that 2 need to go, right? So let me rewrite this real quick. I'm taking integral 0 to 2. I'm going to move them in the y position, x squared minus 1 cubed x dx, right? And instead of that, I have 2x dx here, so it means I need to divide 2 both sides, right? So I actually have 1/2 du equal to x dx. So this is the substitution part, right? And then the new stuff here is that I need to figure out the new u limits. So we need to new u limits. So we know that u equal to x squared minus 1, right? So, and we have x equal to 2 and x equal to 0. So if x equal to 2, then u equal to 2 squared minus 1, right? So this is 4 minus 1, which is 3. That's my new u upper limit, right? And then if I use the lower limit, which is x equal to 0, right? Again, u equal to x squared minus 1. So 0 squared minus 1 is -1. So those are my new lower and upper limit. All right, how does that work? Let's see. I'm going to have my new limits, lower, upper, and then x squared minus 1 is my u, right? So u go here, cube, and then x dx equal to 1/2 du, okay? So a lot going on here. We put in the new u limit because I have u here, and then I replace the u part, I replace the x dx part, okay? So after that, we can start taking integral, right? So I can pull a 1/2 out, and then u to the third du. So, and then start taking integral 1/2. This will mean what? 1/4 u to the 4. And then after I take the integral sign is gone, right? But I need to write down my new limits, 3 and -1. Are we okay? Alright, so this basically, I really should not put this here. It just have the limit at the end. So this basically means the two are multiplying together, right? So we're going to have 1/8 u to the 4, and then I need to plug in 3 and -1, right? So you can just plug in u, because like you can multiply the 8 after that, so probably that would be easier. So I'm going to have 1/8 inside. I first plug in 3 raised to the 4th power. And then I'm going to subtract my -1, the lower limit, and then also raised to the 4th power, right? Okay, so that would be 1/8 times 81 minus a 1, right? This is positive 1, okay. And then we have 1/8 times 80, so basically 10. So this is the first example. I know it's a little bit more complex with a lot of stuff going on. I'm going to post extra video from another teacher in case you need to see more example, okay? Alright, let's look at the next page. So the next page have a square root, right? And I know this is chain rule because square root can be rewritten as 1/2 power. So I'm going to let u equal to the inside part, which is 5x squared plus 4. Then du is going to be 10x dx, right? And I don't have a 10 here, which means I probably need to divide both sides by 10. So 110 du will equal to x dx. So this is just the u and the du parts, and then I also need to figure out the new u limits, right? Okay, so one of them is x equal to 1, one is x equal to 0, right? And then u equal to 5 times 1 square, according to this u, plus 4. So it's just 5 plus 4 equal to 9. And then we have u equal to 5 times 0 square plus the 4, which is just 4, right? So this is my new upper and lower limits, right? So I need to substitute all that in here, but before that, I probably want to rewrite that as exponents, right? So I have the old limit was 0 to 1, x times 5x squared plus 4 raised to 1/2 power dx. Okay, now we got 0, 1, x, 5x squared plus 4 1/2 power x dx, right? So I can replace my u here, du step there, and change the limits, right? So the new steps, my new limit is 4 to 9, and this guy is u raised to 1/2 power x dx. Here is 110 du. Alright, so now first we can pull out the constant, right? So pull out 110 and then 9. Are we ready to take, let's do one more step. 4, and then this is u 1/2 du, right? Okay, so now we're ready to take integral. Let's see. So that is going to be pull down the 1/2, and then you need to add 1, right? so we're gonna have 110 1 over 1/2 plus 2 over 2 u 1/2 plus 2 over 2, and then after that we're supposed to plug in the upper and lower limit, right? So that will turn out to be 110. This is 1 over 3/2 u 3/2. The upper lower limits equal to 110. This flip, so 2/3 u 3/2. Plug in 9 and 4, right? Sorry, 4 here. All right. Now what? Look like we can reduce it a little bit. That would be 5, and then this would be 115, right? And then u 3/2, and then I guess we are ready to plug it in. So plug in the upper limit, subtract the lower limit, right? So 115, you can multiply after we're done with plugging it in. So that would be 9 3/2 minus 4 3/2. So how do you do that? You could do it on a calculator, but this basically means square root and then cube it, right? So 115, you get square root of 9, and then you can cube it. And if you forget how to do it, it's okay to use the calculator to check yourself. Cube. Okay, so that would give me 114. This is like 3 to the 3rd power is 27. I don't know why down 14 is 15 here. 15. Okay, and then subtracting, square root of 4 is 2 to the 3rd power is 8. So 1 over 15 times 19. So basically just 19 over 15. Alright, so a little bit complex with a lot of steps. So hopefully you're okay. So after this part, 27 minus 8 is 19. So I just put 19 over 15. Alright. Okay, let's look at the next one. The next one is similar. Again, it also have a square root, which is 1/2 power, but this time it's in the denominator, so it will turn into a negative 1/2, right? So let's see. If let u equal to 2x plus 1, then du is going to be just 2 dx, right? And I don't have a 2 here, so probably means I need to move the 2 to the other side. So 1/2 du equal to dx. Alright, and then don't forget my new limits. So new u limit. Okay, so if one is x equal to 1, one is x equal to 0, then my u, which is 2x plus 1, is going to be 3. If my u is 2 times 0 plus 1, that would be a 1, right? So those are my new limits. Okay, so let's start doing the integral. So I can have, if I want to, I can go ahead and plug it in. Like this is 3 and 1. I have 1 over square root of u. My dx should be 1/2 du, right? Okay, and then I can clean it up after that. I can pull out the coefficients, and then this means u raised to negative 1/2 power, right? Du. So let's see, we can take integral of that. So we got 1/2 1 over negative 1/2, and then I need to add 1, 2 over 2, u negative 1/2 plus 2 over 2, and then write the limit there. Okay, clean that up. 1/2, this is 1/1/2, u 1/2, right? Alright, so flip that. So this is going to be 1/2 times 2/1, u raised to 1/2 power, and then we will have to plug it in, reduce that. So basically we only have u 1/2 power to plug in, right? So I guess we are ready. So we got 3 raised to 1/2 power minus 1 raised to 1/2 power. So 1/2 power basically mean what? Square root of 3 minus square root of 1, basically square root of 3 minus 1. I can leave it like that. If you want to find the estimation answer, you can use the calculator. Either way would be okay. Alright, if you feel comfortable, you can stop the video and try the next one. But I know this is chain rule because raised to the 4th power, right? So first I'm going to let u equal to the inside part, x cubed plus 1. Then du is going to be 3x squared, right? dx. I don't have a 3 here, so 3 need to go to the other side, divide by 3. So 1/3 du equal to x squared dx, right? So that's the u part. And then the new limit for u, one of my x is 1. One is x equal to -1. So find my u, we got x cubed, so 1 cubed plus 1 is just 2, or -1 cubed plus 1, that would be a 0, right? So this is -1 plus 1. Okay, so those are my new limits. Alright, let's see. I'm gonna move stuff around so it would be in order. 1 -1 x cubed plus 1 raised to the 4th power x squared dx. So I can have my u here, x squared dx match exactly, perfect. So I can change it to the new limit, which is 0 to 2, and then this is my u to the 4th power. X squared dx is 1/3 du. Alright, so that's done. I can pull out the 1/3, right? 1/3, and then we got 0 to 2, u to the 4th du, right? Okay, let's see. Now we're ready to take the integral. 1/3, so this would be 1/4 plus 1, right? And then u4 plus 1, sorry, take me one more step. And then 0 to 2 is like 2 in the morning. I'm a little bit tired. Okay, so 1/3, this is 1/5 u to the 5th power, plug in 2 and 0, right? So I think we are ready to plug it in. Okay, so one more step. So let's multiply this fraction together first. 1/15, right? So I only need to plug into the u part. That will make things a little bit easier. Alright, so let's plug it in now. 1/15, 2 need to raise to the 5th power, subtracting 0 raised to any power is going to be 0, right? Power. Okay, so 1/15, 2 to the 5th power is 32. So kind of like a 32/1, so it's just 32/15. Alright, so once you get a hang of it, hopefully it's not horrible, but you do need to practice. It doesn't come natural to people, so practice. Let's do maybe 2 more for this video. So the next one come with e. So this part is the chain part with the functions. This give it away as chain. rule for e. So I'm gonna let u equal to the x squared. So du is going to be 2x dx, right? I have a 2 here, perfect. So let's go ahead and find the new u limit. So I got x equal to 2, x equal to 0, and u equal to x squared. So 2 squared equal to 4, and then u equal to 0 squared, still 0, right? So those are my new limits. Ready to plug it in? Alright, I'm going to put them in order first. 0 to e to the x squared, and then my 2x dx together, because this is the du, right? Alright, so now I plug it in. New limits, 0 to 4. I have my e. Replace that with u, and then that would be du, right? Okay, now we're ready to take integral. E to the something, after you take integral, is still e to that, right? And then you need to plug in 4 and 0. So it's going to be e to the 4 minus e to the 0. I don't know what's e to the 4, but I know e to the 0 should be what? 1. So that's your answer. Alright, let's do one more. Okay, so that looks like really complicated, but we can do it. Let's see. It looked like the bottom part is my u, so let's try it out, because I don't want to do a quotient thing, right? I'm gonna let u equal to the bottom part, x cubed plus 3x squared minus 1. Then du will equal to 3x squared plus 6x dx, right? Okay. Look almost like that, but have the 3 too much, right? So I can pull out a 3. So pull a 3x squared plus 2x dx. So if I just get rid of the 3, that would be okay, right? So I can divide both sides with 3. So 1/3 du equal to x squared plus 2x dx. So this matched the bottom part, this matched the top part, right? So that looks pretty good now. Let's find my new u limit. X equal to 2 and x equal to 1, then u, oh, that's the long one, it's going to be 2 cubed plus 3 times 2 squared minus 1. So I don't have a lot of space, I apologize. The top one, u supposed to be 19, and then if x equal to 1, then u will be 1 cubed plus 3 times 1 square minus a 1. So the second u will equal to 3. So I apologize, we didn't have a lot of space here. Okay, but we can use that to substitute in here. So I'm going to put them in order first. Maybe it's easier to see. 1 to 2, if I just pull out this part, multiplying the top part, and then dx. Then it will look like this is my u, and x squared d plus 2x dx would be 1/3 du, right? So, and then I put in my new limits, which is 3 to 19. And then this is 1 over u, this is du, okay? It's a lot cleaner now. I'm sorry, this is not du, this is 1/3 du here. Okay, got it. Okay, so now the 1/3 go to the front, and then still 3 to 19, this is 1 over u, right? Anybody remember what is 1 over x? That's the special one. If you just like do the normal way, you will get a no solution undefined, right? So hopefully by now you know 1 over x or 1 over u mean ln. So ln of u, and then you're supposed to plug in 19 and 3, right? Okay, so you're going to have 1/3 ln of 19 minus ln of 3. Anybody remember a property when it's log subtracting? You can write as a single logged subtraction become division. So this is 1/3. We're gonna have ln 19 divided by 3. Alright. Okay. So it requires lots of different skills for this one. Let's stop here and then we will start one more video. It's okay?